Public interest in archaeology has exploded over the past 2 decades. Major contributors to this increase in public interest are popular programs like Forbidden Archaeology or Ancient Aliens. Programs like this capitalized on a person's innate interest on questioning the status quo. This, in combination with the age of misinformation and our content being created by artificial intelligent bots, has garnered a new area of interest among the public and academia, focused entirely on the trust and confidence that one can have in academics as a whole. For the purposes of this video, it will be archaeology in the spotlight, with a specific focus on the history of ancient engineering. We will examine and deconstruct important pieces of evidence for the purposes of setting bounds in order to separate what is possible from the impossible. In the end, we hope to shed light on two major questions: to understand the upper and lower limits of technological and engineering capabilities that humans possessed throughout history, and to determine if there truly is any reason that we should limit our trust and confidence in the archaeological branch of academic authorities. Welcome to Wild Facts. First, we'll clarify some general aspects of the most widely accepted model by archaeologists worldwide. To quarry the stones, a survey is first done to find fractures that could help aid them in the process. Then, they take advantage of thermal expansion to weaken the stone by building fires around the portions of material meant to be removed. And after the stone is brought to temperature, it is quickly cooled using water. The prepared material is then removed using diorite balls only a little smaller than bowling balls to pound away at the stone. The other method used for separating stone blocks from the source is to use a 2-person copper saw and some aggregate to cut the stone into pieces. After the blocks are removed, transportation from source to worksite is accomplished over water by boat and over land by sled and log rollers. The crudely cut blocks are then shaped, polished, and decorated according to the specifications for its designated purpose, using primitive hand tools crafted from stone and copper. The final step is to place the stones, in some cases without mortar, depending entirely on irregular shapes and irregular lattices, to hold the structure together. But how does this model stack up against the evidence? First, it must be noted that these are highly generalized aspects of the archaeological models used to explain ancient engineering. And so, agreement among experts is not universal. With that said, let's begin with how the stones are quarried. Using evidence found at Egyptian quarries, the most widely accepted model claims that stones were removed from their source quarry by first planning the stone's removal around natural fracture sites, followed by removing material by pounding it away with bowling ball-sized diorite stones, aided by thermal expansion. The question is there any evidence that contradicts this narrative? Those who have seen pictures like these would say yes, especially engineers. Evidence of precise boring into the stone and of workers backing out of accidental plunge cuts made by circular saws paints a different picture. The most damning evidence contradicting this narrative was collected during the examination of drill cores found in the area. This evidence comes in the form of 2 measurements regarding the properties of the threads or tool marks that spiraled down the cores. Those measurements are slope and slope consistency. The slope or incline of the spiral tool marks that run down the length of the core contains periodic displays in which the tool marks are incredibly consistent, indicating the ability to precisely and continuously manage both pressure and speed of the drill across the length of each period, meaning a highly adaptive source of power must have been present. The slope of these tool marks were also found to be incredibly steep. This measurement has a direct correlation to the energy output or the feed rate of a drill. These measurements indicate that the drill responsible for creating these cores was capable of feed rates hundreds of times greater than even our best modern drills. So, what does this mean? Is there good evidence to suggest that the most widely accepted archaeological models about human history are incorrect? And if so, does this give the public good reason to limit the amount of trust they have in the individuals responsible for archaeological investigation, and therefore limiting the amount of confidence they have in the conclusions to which they came? It's at this point that I have a confession to make. You see, I purposely selected archaeology for this video due to the level of circumstantiality and subjectivity inherent to the field. This is based on the objective confidence that someone can have based on the language used to communicate the concepts within a given field. This has no relation to the level of trust or credibility that should or shouldn't be placed in the individuals responsible for communicating or investigating. I also purposely selected Egyptology as the specific branch from archaeology because of this guy. This is because Zahi Hawass, in my opinion, is a meme representing the debilitating inclusion of politics within an academic field. With my sarcastic confession out of the way, we can now answer the questions about accuracy and credibility. When it comes to accuracy, it would be wildly improbable if the models posed by the archaeological community were completely correct, and there is a significant amount of evidence to suggest major changes may need to be made in order for these models to fit the evidence. However, credibility should play an extremely limited role when considering scientific investigation, and only serves to slow down scientific progress. Therefore, credibility should play zero role in the level of confidence the public has in the scientific community, and it should also play zero role in the peer review process of the scientific method. Instead, it would be best to learn to distinguish between arguments that are made scientifically and therefore criticize the science, rather than arguments that are made politically and therefore criticize the scientist.